the start of a new period. So what do we do when we get to a new period? What happens? We have a new energy level. Ons het 'n volgende nuwe energievlak wat dit nog groter maak. Nuwe orbitale, new orbitals. So every time it's like you have a typewriter. Weet jy daar's 'n typewriter, 'n tikmasjien? En dan ting, gaan ons na die volgende ene toe en dan sit jy nog 'n lyntjie by, nog 'n lyntjie by, nog 'n lyntjie by. So jy maak die paragraaf groter. Okay. So they're all the start of a new period. Thus adding another orbital or energy level. Dus voeg jy nog 'n orbitaal of energievlak by. Dus voeg jy nog 'n orbitaal of energievlak by.
Juffrou, hoekom word die atoomradiusse nou weer kleiner?
Goeie vraag.
Want dis mos nou 'n nuwe orbitaal, so moet dit dan nie dieselfde bly hierdie periode nie, want dis
Ek wil even daaraan dink, ek gaan jou nou die antwoord vra.
So is dit hierdie 2 is die 2p.
Dis seker gelink daaraan. Dink nog. Owen, ek wil by jou weet, soos wat ons beweeg van lithium na neon. Okay, jy jou periodieke tabel langs jou oop. Van lithium na neon. Ons sien dat die radius kleiner word. Okay? So gee vir my die patroon wat jy daar waarneem. Die patroon wat jy waarneem van lithium na neon. Moet dit nie oordink nie. Sê net wat jy sien. Ja, ek wil hê jy moet my vergelyk die atoomradius met iets wat hulle almal in gemeen het. Wat het hulle almal in gemeen? So my question is, what do they all have in common? And how does that links with the atomic radius? Wag net. Ja, Owen? Okay, so is almal in dieselfde periode. They're all in the same period, period 2. En waar sit lithium in periode 2? En waar sit neon? Okay, so soos wat jy gaan van links na regs, neem die atoomradius af. So as you move from left to right in a period, the atomic radius decreases. Okay, so ek gaan vir jou vra, watter patroon neem jy waar? What pattern do you see from lithium to neon? Refer to periodicity and radius. So as you move from left to right on the periodic table, the atomic radius decreases. Ja, George.
Juffrou, hoekom word dit langer maar die atoommassa word dan groter?
Dit is Reiner se vraag ook. Okay. So what now? So as julle hierso kan sien, as you move from left to right in a period, it gets smaller. What made sense to us is if you go down in a group, it gets bigger. That made sense to us. Okay, because you add another period. No. Maar hoekom neem hy af van links tot regs? Okay, so when you get to a question like that, you must ask yourself, what changed? Wat het verander? The period did not change. Hy is in dieselfde periode. Maar wat het verander van links na regs? Die hoeveelheid protone en elektrone. So here at lithium we have 3 protons and 3 electrons. And at neon we have 10, né? So we have 10 protons and 10 electrons. Hy is definitief digter. Okay, maar hoekom is hy digter? Hoekom is hulle nader aan mekaar? Because as you move to the right and you add sorry about that. That is protons is 10, electrons 10. Proton 10, electron 10. You add more positive things and you add more negative things. Dis asof jy die magneet groter en groter maak. Hier het jy 'n piepklein magneet, want dit is aan 3 goeder, small magnet. And here you make the magnet bigger, so now you have a big magnet. Nou as jy 'n klein magneet het, the pole is relatively small. En as jy 'n groot magneet het, dan is die aantrekkingskrag groot. So if the attraction force is bigger, the outside electrons are attracted by the nucleus much stronger. Plus nader. En daarom neem die atoomradius af. Are you with me? Yes?
Yes.
Parabelo, what is daarom neem hy af mean in English?
That's why it goes down.
Right. Okay. So don't have to translate everything. You got it. Eh? Okay. Right. So here I explain it to you. What I just said, everything I just said is explained here at the bottom. It says, if we look at, it increases from top to bottom in a group. So in a groep, as jy so afgaan. Hoekom neem dit toe? Want we add an additional energy level. So is dit nog 'n energievlak by. An increasing number of full electron orbitals have a screening effect. 'n Afrikaanse afskermingseffek. Okay, so that is what I explained. I said if it becomes bigger, you add more energy levels. Dan so buitenste elektrone, the outside electrons and the nucleus do not have such a strong pull on each other. If there's just one orbital, then it will be a bigger pull, want hulle is nader aan mekaar. Sal jy weet my? Ja? Okay. So there's a screening effect causing the attraction force, the aantrekkingskrag, to weaken. Remember, this is not a coloring book. Hy's nie 'n inkleurboek nie. Ja, highlight nie alles nie. Okay. Then if we look at a period, then it decreases from left to right. Hy neem af van links na regs. Oei, en dan kan jy sien wat ek highlight daar. Ek het al weer die ondersteen goed gehighlight. Niks.
Daar's iets maar nou nie sien.
Okay, kom ons kyk gou. Wat se kleure moet ek gebruik, juffrou? Groen. Okay, ek gebruik eintlik verskillende kleure, hoor, maar anyway. Okay. Right. The electrons added per period are all in the same energy level. So dis belangrik. Electrons added per period in the same main energy level. So dis nie dat jy nog orbitale bysit nie. It's in the same orbital, you just add more. Okay, so you don't make it bigger, you just make it stronger. Okay. Thus, all more or less at the same distance from the nucleus. However, the positive nuclear charge also increases. Jy sit nou nog protone by. And the attraction force on the electron cloud also increases. So the atomic radius shrink and the radii decreases. Okay, good. Then the last thing there is electronegativity, electronegativiteit. Okay, now you can scratch that one N, there should only be one N, EN. Okay, it says there, the electronegativity of an atom is the measure of its attraction, the mate van sy aantrekking, on a shared pair of electrons in a bond between that atom and another. Okay, goed. Nou ek wil hê jy moet gou vir my kyk op jou periodieke tabel, on your periodic table. In the middle there is a key. Okay, so hierso in the middle is daar 'n sleutel, right? Now we've done two of the things. We've done at the top the atomic number, die atoomgetal, dit ken jy nou, aantal protone. Dan hieronder het jy die massa, the mass. Mass is the protons and neutrons. Then on the left-hand side, is 'n nuwe ene. Sien jy daar staan electronegativity, elektronegativiteit. Okay. Now scan jy jou periodieke tabel, you look there, you see, okay, here on the left-hand side of the metals, by die linkerkant by die metale, sien jy dis klein, 0,8, 0,9, 2.1, relatively small. And as you move to the right on the periodic table, it becomes bigger, where you have fluorine that is 4, fluor is 4. And then when you get to the noble gases, they have nothing. Okay. Now, what is elektronegativiteit? Hulle sê the measure of its attraction, hoe sterk dit aantrek wat 'n elektronpaar. Do noble gases want to attract electrons? No. So that's why they have zero electronegativity, want hulle soek soek niks. Okay? Metals, do they want electrons or do they want to give away? Give away. So you can see the electronegativity is small. You can see the non-metals, die metale is baie hoog because they want an electron. Nou, dit is sommer kom ons vra. Juffrou, jy doen onder dit hulle dan niks. They have nothing there. It's because most of them are synthetically made, syntheties gemaak. They only last for a few split seconds. So ons weet nie of hulle elektrone wil hê of nie wil hê. Okay, but we think they don't want electrons because they are so heavy, they just shatter into pieces, they break apart. As soon as you make it, they break apart. So they don't want anything. Yeah.
Is that also why they don't have a mass?
Yeah, we have a relative mass for them, but we're unsure. Okay, good. Now you can see there, we have on this periodic table, we have electronegativity, and we have atomic number, atoomgetal. Yeah. Want goud wil, het jy al gesien dat hy met goeders reageer spontaan, so sê nou maar jy het 'n ring of hangertjie van goud. As jy hom daar neersit, sal hy oormôre opgebreek het en gereageer het. Nee. So goud is een van jou baie min elemente wat glad nie wil reageer. So hy wil nie goeders aantrek. Okay, so you can see the atomic number, the atoomgetal, dan begin ons by 0, and then we have hydrogen, helium, so that's actually 2, then we have lithium, beryllium, gaan jy op, tot by fluorine, and then we have neon, en dan het jy, wat is dit, natrium, sodium, and then you go pop. So, ons kan sien hier, let me just write down, excuse, we have here, joh, jy kan regtig mense nie vrou vir 'n nuwe ding kry. Daai is fluor, daai is chloor, daai is brom. Okay. So again I want to know what is the pattern, the trend, wat is die patroon, die tendens? En so hier onder begin ons by wat is die ding se naam? Natrium. Okay, nie natrium en lithium. Sorry, lithium. This is lithium. And then goes up. What is the pattern in a period, Courtney? What is the pattern in the period regarding electronegativity?
Size will.
No, I'm not busy with size. I'm busy with electronegativity and in a period.
The attraction will decrease, so they don't want it.
There's a decrease.
Increase.
So I want you to say, as you move from left to right in the period, the electronegativity increases. Okay, and then I want to see in a group. Okay, so let's look at fluorine, chlorine, and bromine. As you move down a group, what happens, George? No, jy bewoording, George. Soos wat jy afbeweeg in 'n groep, neem wat af? Ja. Ja, jy kan. Okay, right, so as you move down a group, the electronegativity decreases. Ek dink ek het dit heel onder gesê. So, it decreases from top to bottom in a group, and it increases from left to right in a period. Okay. So hierbo verduidelik ek net so 'n bietjie meer van elektronegativiteit. A clever guy named Pauling allocated electronegativity of no unit. So it's not 2.3 newtons of wat ook al, is geen eenheid nie, no unit, of 4 to fluorine. So hy het al die elemente met mekaar vergelyk. He compared all the elements with each other, and then he saw fluorine is the most reactive. Fluor gaan enige elektron wil aangryp. So he said 4 to fluorine, the strongest element with the highest electronegativity. Sterkste element met die hoogste elektronegativiteit. En daarom het dit die sterkste aantrekkingskrag, the strongest attraction force on a shared electron pair. En dan, the other elements are comparative values. Vergelykende waardes. Okay? Dis is as ek sê, alright, the perfect student is Carabello. He always does his homework, he takes part in sports, he's always on time. I kry 'n A gemiddeld, this is the perfect student. And then I compare all of you with him. Colby, I just swear oulik soos Carabello nie, so Carabello se 10 uit 10, dan is hy 'n 9 uit 10. Okay, so that is what Pauling did with the elements. He said fluorine is the strongest one, 4, and then he compared all of the other elements with 4. Okay, so hierdie waardes is nie iets wat jy kan gaan meet nie. It's not something you can go measure. Dit is 'n vergelykende waardes wat hierdie ou he did with a lot of experiments, he got to that answer. Okay, so you can see from left to right, it increases with fluorine being the highest, and from top to bottom, it decreases. Okay, goed. Nou wil ek hê ons moet gaan na bladsy 8, page 8. So you would have had homework, but now we're going to do the homework together in class so that we are done with this chapter. So see it off here. The lithium atom has an atomic radius of about 152 times 10 to the power negative 12 meters. This piep klein. Lithium ions have a smaller radius. Okay. Nou kom ons stop net gou vinnig daar. Waar trek ons? Jy het geantwoord. Reinhard, wat is die verskil tussen 'n lithium atoom en 'n lithium ion?
'n ion het 'n elektron verloor of hy.
Okay, so an ion is something that it lost or it gained an electron. Or more, electrons or electron. Okay, so as ons kyk na lithium, and we compare it with the lithium ion. Okay, I'm going to zoom in there at the top. Erich, lithium, hoeveel elektrone? 3. 1, 2, 3. Kienan, die lithium ion. Hoe lyk hy nou? Kyk nou, ek het jou periodieke tabel langs jou oop. Lithium ion, wat sal sy valensie word?
Dit hoef lekker om na die ander kant.
Plus 1. So mooi. So the lithium ion is plus 1. It meant it lost an electron. Het 'n elektron verloor. So Relo, how many electrons does it have now? How many electrons does the lithium ion have? 2. 1, 2. Okay. So Zara, lithium originally had how many protons? 3. And how many electrons? 3. 3. You're thinking of neutrons. Okay? And now, how many protons does it have after it became an ion? Protons. Can it lose or gain protons? No. So it still has 3 protons. How many electrons does it have? 2. So can you see that the number of protons remain the same? Die proton het presies dieselfde gebly. Sy positiewe aantrekking het dieselfde gebly. Dis net 'n aantal elektrone wat minder geword het. Okay. Now here we will let's say have an attraction force of 10 newtons. So that is 1. Daai aantrekkingskrag, that attraction force, François, dink jy hy's groter of hy's kleiner? Jy het R100 in jou rekening. Nou steel ek by jou R50. Gaan jy daai R50 net so los? Nee, jy gaan vashou aan hom want iemand moet net nie nog daai R50 ook steel nie. Nee? Okay? So daai aantrekkingskrag word nou nog sterker. Okay? But then also, here we have actually a second energy level. 'n Tweede energievlak, orbitale en. Here, there's no second energy level. Want daar's niks daar. So, this has a second energy level. and it will influence the size. En dit het nie 'n tweede energievlak nie, so is obviously kleiner. Okay, so kom ons kyk of dit vir ons sin maak hier. It says there, the atom has this radius and the ion has this radius. Okay, that on it. So we can see it did become smaller. Hy het wel kleiner geword. Dit maak vir ons sin. It makes sense to us. Okay. Nou is die eerste vraag daar. Write down the electron configuration for the lithium atom. Elektron konfigurasie, Ricardo. Vir die lithium atoom. Daar het ek vir jou die afbouw diagram geteken. Jy moet dit gebruik om jou te help. Wie bel jy? François? Incoming call? Of is dit pauze al? Antwoord gauw? Oh my word, dis 1S2, 2S1. Okay. Oh ja. Alright, so I see assembly is done. Okay, ek gaan nie julle pause steel nie. Dink julle reg, wag net vir, dink julle reg of dit nog klaar? Ja, Alright, we will continue in the next class and then we'll start the next chapter.